Yo, welcome back. It's day 4. It's Advent of Code time. So we're gonna be chilling here. We're gonna be doing coding problems. If you missed the last 3 videos, every day we've been doing an Advent of Code problem in Elm. This is Advent of Code. Every day, 2 problems or 1 problem with 2 parts gets released, and we've been basically going through them, doing them together. I haven't seen the problem yet. What we're gonna do is we are gonna look at the problem together, and then we are going to do it in the browser using Ellie. Ellie is basically the code pen for Elm, and so it allows me to type stuff over here and then hit compile and then see the code run on the right. So we're going to take the puzzle input, we're going to write a bunch of code together. I'll walk you through my thought process step by step, and hopefully by the end of it, we will get 2 more gold stars to go with our 6 for a total of 8. So yeah, that's pretty much the whole spiel. Let's get started with day 4's problem. Yeah, opening it up. Day 4, scratch cards. The gondola takes you up. We were on a gondola yesterday, in case you missed it. Strangely, though, the ground doesn't seem to be coming with you. You're not climbing a mountain. As the circle of Snow Island recedes below you, an entire new landmass suddenly appears above you. The gondola carries you to the surface of the new island and lurches into the station. As you exit the gondola, the first thing you notice is that the air here is much warmer than it was on Snow Island. It's also quite humid. I don't know why they're bolding these words. Is this where the water source is? The next thing you notice is an elf sitting on the floor across the station in what seems to be a pile of colorful square cards. Oh, hello, the elf excitedly runs over to you. How may I be of service? You ask about water sources. I've forgotten the plot of this, so I don't even know what's going on. I'm just reading crazy sentences. I'm not sure. I just operate the gondola lift. That does sound like something we'd have, though. This is Island Island, after all. I bet the gardener would. Oh my gosh, it's taking forever. Blah, 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 blah. I'll let you borrow my boat. You can go visit the gardener. I got all these scratch cards as a gift, but I can't figure out what I've won. The elf leads you over to the pile of colorful cards. There you discover dozens of scratch cards, all with their opaque covering already scratched off. Picking one up, it looks like each card has 2 lists of numbers separated by a vertical bar, a pipe. List of winning numbers, and then a list of numbers you have. You organize the information into a table, which is our puzzle input. As far as the elf has been able to figure out, you have to figure out which of the numbers you have appear in the list of winning numbers. The first match makes the card worth 1 point, and each match after the first doubles the point value of that card. So here we have the winning numbers on the left, and then a list of the numbers that we have. So in the example above, card 1 has 5 winning numbers, 41, 48, 83, 86, and 17, and 8 numbers that we have. 83, 86, 6, blah, 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 all the way to 53. Okay. Of the numbers you have, 4 of them, so 48, looks like that's in both, 83, 17, and 86. Looks like those are matches. They're winning numbers. That means card 1 is worth 8 points. 1 for the first match, then doubled 3 times. So 1, 2, 4, 8. That's how we get 8 points for that card. Card 2 has 2 winning numbers, so it's worth 2 points. Card 5 has no winning numbers, worth no points. In this example, the elf's pile of scratch cards is worth 13 points. Take a seat in the large pile of colorful scratch cards. How many points are they worth in total? All right, so this is going to start as another parsing problem. And what we're going to be doing is we're going to be trying to get lists of numbers. We're going to loop through them and see how many matches we got from this list. So I think this is going to be a straightforward one, but maybe part 2 is going to have a crazy twist. So we'll get started. This is a Ellie template. I'm going to share the link in the description for the starter template. If you want to follow along, you can pause right here. And all this is going to do is allow us to see our value change over time on the right. So let's dive into it. So the first thing I'm going to do is I'm going to use string.lines function. I think we've used this in every puzzle, and that's going to break up this single string into a list of strings. And then what we can do is we can handle each card one at a time. So what I'm going to do is a list.map, and we're going to say to, what do they call it, scratch card. And we're going to start by making, like it, we're going to start by making a function that takes in each line and then we're going to return a data structure. So right now, each line is just a string. What I want to do is have a scratch card data type. So let's define that here. It's going to have winning numbers, which is a set of integers. The set is just like a list, except it doesn't have duplicates, and basically it'll allow us to quickly check is this number a member of the set or not. We used that in the last video too. An important thing is we're going to need to make sure that we import this. So we have the winning numbers, and then we have our numbers, which is also going to be a set. So what we want to do is take this line and we want to convert it into a scratch card. So when I run list.map on this string and I don't do anything, right now it's just going to spit out everything as it came in. But if I wanted, I could start to do transformations on every part of this list. So if I wanted to split every line with this pipe, you'll notice that now the first member of my list has the stuff to the left of the pipe, and then another element here, which is the stuff to the right of the pipe. So what I want to do is I want to do some pattern matching. So I'm going to say, in the case where I split the line up, and it's got a left side and a right side, and then nothing else, so like an empty list, then I want to keep going here. So let's just say we'll return the left side for now. And then in the case where there's something wrong, we basically want to throw away this value. We'll say this is no good. And we can say, let's just ignore the case where we have an invalid line of text. Like if we had something like this, we're just going to throw away that scenario. We're only going to keep lines that are valid for our little parser here. So if I run this, right now it's going to filter out all of our numbers, and we're just going to see, card 1, colon, all that stuff. And one thing I'm going to add up here, now that we have a maybe, is the filter map function that we used in previous videos. Again, filter map is just a map that gets rid of all the maybes. So it'll keep any maybe that has a value, and it'll discard any nothing. So we'll just get rid of those annoying prefixes that we were seeing, all the just stuff being printed out. So filter map's really common when you're working through a list of values that might not be valid. So what we want to do is we want to take the left side and we want to keep splitting it. So we want to get rid of this card1 prefix. So what we're going to do is we're going to say case string dot. Actually, we're just going to do a drop left. Actually, I don't think we can do a drop left. Let's just split on the colon space here. And that'll allow us to do a similar thing where we have left side card, then we have the card with number string, and then we're going to have the actual, this is like the winning numbers string. This is going to be the our numbers string. So we're going to take the left side of the card, we're going to split it. If it's a perfect split, if there's just card 1 on the left side, or card 2 or card 3, and then and then we have all our winning numbers on the right side, then we're going to keep going. We'll say, let's do just the winning numbers string. So this is dialing it down even farther. And then if we have 0 after the split, 1, 2, 3 elements, we just want to say this is an invalid input. We're going to throw it away. So here, what we've done so far is we have narrowed it down to get into just the winning numbers for each line. So we still have access to the information, but right now our function is only returning this, and that's why we're seeing it in the output. So we haven't actually lost this info. It's right here. We just need to return it with the toScratchCard function. So the way we can do that is we can say, let's say the winning numbers is going to be, and I'm going to say toSet string, and I'm going to pass in the winning numbers string. And then for our numbers, we're going to say toSet string, and then we're going to pass in the our numbers string. So what we can do here is we can return a scratch card type. So the annotation that we'll finally be able to write here is I'm going to take in a string, and I'm going to return a maybe scratch card. And so what we need to implement is something that takes one of these strings and turns it into a set of integers that we can work with. So let's do that. So this is going to be our string. Just going to do all string, all lowercase. And what we can do is we can say, take our string of numbers. So take this guy here. We're going to split it with spaces. So we've used that split function a lot. Now that we split it with spaces, what we're going to end up with, let me use comments to annotate kind of the value as we go. So we have a toSet from string. It's going to take in a string, and our goal is to return a set of integers, which is what both of these fields are expecting to be returned, as we call them here. So when we start, our input is just a string type. So that's a string. When we do string.split, it transforms our string into a list of strings. So we're going to have a list where each number is wrapped in quotes. And then what we can do is we can do a list filter map, and then we can say string.toInt. So for any of these individual chunks that are valid numbers, we're going to keep them. If we had something silly in here, like XYZ, it's just going to throw it away. So we're going to assume that the puzzle input's valid, and any crazy stuff is just going to get left out. So to show you what the type is going to be here, at this part, because we use filter map, it's going to be a list of ints. And again, if we used list.map, we wouldn't have a list of integers. We'd have an annoying list of maybe ints, and it'd have all those weird justs in the front. So filter map is going to help us clean out that noise. So if you have a list of ints, what you can do is you can call set from list, and this is going to take in the list of numbers, and it's going to return a set of numbers. And again, that set data structure comes with really helpful methods. Let's open it up. Trigger warning, it's going to be very bright. And so set has a really nice function in it called member, where you can just give it a number and it'll say yes or no, like, is that in the set? And we can also use a function called union, which is going to, or intersect, which I think is going to tell us how many overlapping values there are. But we'll see if that's what we end up doing. So this code takes our string, turns it to a list of string, then a list of int, and then a set of integers. And by the end, when we run this, hopefully we're in a good place. Let's see what I screwed up. Set from list. Oh, it needs to be a maybe scratch card. That's right. So because I didn't wrap it in just, it wasn't returning a maybe, it was returning an actual scratch card. So that's the code for turning it into a scratch card. So let's see if, for the first number, if we got the correct result. And keep in mind, a set is going to order things by value, so the numbers might be jumbled here. So for our winning numbers for the first thing, we're seeing 17, we see a 41, we see a 48, we see an 83 and an 86. That looks good. And then for our numbers over here, we're seeing that there's a 6, there's a 9, and I'm just reading this, by the way. No, that's the numbers I'm reading out loud. We have a 6, we have a 9, we've got our 17, a 31, a 48, a 53, an 83, and an 86. So it looks like we have the right numbers in our data structure. And now that we have a list of these scratch cards, we're going to be able to filter out, or we're going to be able to use list.map to find the score for each scratch card. So no longer have to worry about weird strings. Now we can take a toScore function, and all we need to do is define a function that takes a scratch card and gives us back an integer, which is what is the score that we have. So before I add this annotation, let's start with our scratch card. And let's just print out 0. So for all of these, if we return 0 for everything, that's what would be spit out. We'd have a list of zeros here for each game. But that's not the right answer. What we want to do is we want to see what are the intersections of these two sets. So I'm going to use set.intersect, which is a built-in function in the Elm library. Not every programming language has this right in the core library. It's usually like a package you'd have to install. We lucked out. Scratch card winning numbers, we're going to intersect that with our numbers. Let's see what we get for each result. So here it's saying that the overlap here and here is 17, 48, 83, 86. And so that's 4 points. What I want to check is that the puzzle doesn't duplicate numbers, because if it does, then we're gonna, if we have like two 17s, for example, and we need to score those twice, this intersect function isn't going to be what we want. But let's just check it out. So each card has two lists of numbers, list of winning numbers, and a list of numbers you have. So I don't see anything talking about, I don't see anything in the puzzle input saying that you could have two of the same number in your number list. So I'm going to assume for now that this is okay. And what we're going to do is we're going to take a look at the matches we found. So here we found 17, 48, 83, and 86. Here we have 17, 48, 83, 86. Here, for the second one, we found 32 and 61. Sure enough, 32 and 61. And then for card 3, we had 1 and 21. And for card 4, we had 84. And it looks like that's what we're getting, 1 and 21, 84. So I think our code is right. We've got this annoying set.fromList thing going on, but we can convert that in a second. So we can say, this is our intersection. We can say set.toList. So then this is how many matches we found. If we want, we could actually go straight to the length of the set. So how many numbers are in each thing. Does set have a length function? Set.size. So size is the function, not length. Go. Set.size. So 4, 2, 2, 1, 0, and 0. And what we want to do is we want to take that, and then based on the size we have, we're going to say put 2 to the power of whatever the score is minus 1, if it's greater than 0. So let's just say a number of matches. It's going to be an integer. So we're going to say if the number of matches, we're just going to say, is less than or equal to 0. It shouldn't be possible to have negative matches from intersect, but just want to make sure we cover that case. If you have less than or equal to 0 matches, you're going to get 0 points. Otherwise, you're going to get 2. Is it basics.pow? Let's just say it's 2 to the power number of matches minus 1. Let's see if this gives us the score that we're expecting. Oops, I forgot to do an equal sign after this. This is it. So it looks like that's correct. I think 8, 2, 2, and 1 is right. And then what we want to do at the very end, and this is my favorite part, we seem to be doing this in almost every video, we get to call list.sum, we hit compile, and then we get 13, and that is the answer that they were expecting in the puzzle. So we're in good shape. So what I'm going to do is I'm going to go here. I'm going to save this. We got day 4, part 1. And I am going to save this. And I'm going to copy this into the clipboard. Actually, I'm going to do something different than what we've done in previous videos. I'm going to duplicate this tab, and we'll just keep this one pinned to the left. So that's our part 1 answer. And we can keep going for part 2. But before we do that, we need to check to see if our answer is right. So I'm going to get my, my puzzle input. This is going to be different than yours. So our numbers won't be the same if you have an Avenant Code account. But when I run this, my answer is 32,609. Let's see if that's right. Sweet. All right, we got the right answer for that one. So what we're going to do now is we're going to take a look at part 2. There's going to be a twist on the problem. Maybe there will be duplicates this time around. That's my prediction. And we'll see how we have to tweak our part 1 code to make it work for part 2. Fingers crossed that it's just the duplicate thing, because I think that's going to be easy peasy. All right, part 2. Part 2. Just as you're about to report your findings to the elf, one of you realizes that the rules have actually been printed on the back of every card this whole time. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards equal to the number of winning numbers you have. Specifically, you win copies of the scratch cards below the winning card equal to the number of matches. So somehow they're handing out scratch cards, and based on how you randomly stack them, that's how they work, which is kind of crazy. Specifically, when copies of the scratch cards below the winning card equal to your number of matches. So if card 10 were to have 5 matching numbers, you would win one copy each of cards 11, 12, 13, 14, and 15. Copies of scratch cards are scored like normal scratch cards and have the same card number as the card they copied. So if you win a copy of card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original card 10 won: 11, 12, 13, 14, and 15. This process repeats until none of the copies cause you to win any more cards. Cards will never make you copy a card past the end of the table. All right, this is crazy. So I'm terrified. Maybe it's simple. Maybe it's nuts. It sounds nuts. It was not the thing I predicted. All right, card 1 has 4 matching numbers, so you win one copy each of the next 4 cards. So because this had 4 matches from before, we're going to win a copy of cards 2 through 5. Your original card 2 has 2 matching numbers, so you win a copy of 3 and 4. Your copy of card 2 also wins 3 and 4. Your 4 instances of card 3, which is the original one, and then it got copied once by 1 and it got copied twice by 2, gives us 4 copies. This is nuts. And the 8 instances of card 4. So I have 8 copies of card 5. There's 14 instances of card 5. I have no matching numbers and win no more cards. Your 1 instance of card 6 has no matching numbers and wins no more. So once all of the originals and copies have been processed, you end up with 1 instance of card 1, 2 of card 2, 4 of card 3, 8 of card 4, 14 of card 5, and 1 instance of card 6. In total, this example pile of scratch cards caused you to ultimately have 30 scratch cards. Process all of the original and copied scratch cards until no more total scratch cards are won. Including the original set of scratch cards, how many total scratch cards do you end up with? So we're adding up how many scratch cards we're going to have at the end of reading our scratch cards. And then that number is going to be the answer that we put in the puzzle. So in this, the answer was 30. So what I'm going to do is I'm going to Control Z. I'm going to hit compile. We're back to 13. So I don't forget that we're working on part 2 here. I'm going to save this as part 2. Let's get into it. Let's try this out. So I'm going to back up a little bit, and we're going to go back to our data structure. So I'm happy that we ended up with this. We actually have a data type that we can work with. I think toScore is doing too much. It's for this puzzle, I don't think we want to do all this calculation yet. So I'm going to say toNumber of matches. Let's do toNumber of matches as a kind of a separate thing that takes a scratch card and it just returns the number of matches. So instead of doing this let expression, we're going to just do this. So number of matches. I don't know how I did the copy like that. That was crazy. This is going to take in a scratch card. Scratch card. Every time I type scratch card, I get a little less confident that I spelled it right. There's something about the word scratch. It's got too many C's and T's, and it's overwhelming. Okay, there's one T, but whatever. Set of it. So let's just start with toNumber of matches and see if that is a good spot to leave off on. Oh, sorry, this is just going to be. So we kind of backed up here, and now we're left with 4, 2, 2, and 1. So this is kind of interesting. So we're going to start here, I think. This is like the last part where our code made sense. What I'm going to do is get rid of this toScore function. I don't think we're going to be using it. And if we need it, we can just go back to the last puzzle. And I'm going to just get rid of these comments. Elm format kind of formats these things in an annoying way. So we're going to leave it there. So we have our number of matches. What we need to do is say, okay, 4 is going to basically copies of this. So we're going to have a number that we're incrementing, and then we're going to keep going. So I think what I want to do is have a dictionary where I have the card number. So like 1, 2, 3, 4, 5, etc. Like all basically the indexes plus 1. I want to have those card numbers. I want to keep track of how many I have total. So in the very beginning, what the dictionary's value would be is it would be like, all right, you have one, you have one card two, you have one card three. And then what I want to do is I want to go through each number, and then I want to increment. I want to increment, like add 4 copies of this, and then take that into account when I'm figuring out the next set. I think that's like the general idea. That might have been confusing in English, but let's see how it goes. So here I'm going to say we have our number of matches. I'm going to say 9 total scorecards. We're going to be bold here. We're going to say that this function is going to return that number eventually. So what we're going to start with is actually a list of numbers. It's like how many matches we have. And what I want to do with the list of matches is I want to start by saying card count. So our card count is going to be how many total cards how many total cards we have. So in this puzzle, we're going to use the length of the list. We're going to say list.length, these lists of matches. And so hopefully by the end of this, if we return this as is, card count would return that we have 6 cards. So if I compile, I want to see 6. Great. So I'm going to start with that. And then what I want to do is I want to make a I want to make a dictionary. 1 to the card count. I'm going to do list.map. So okay, sorry, let me slow down. I think I'm doing a lot here. So if I hit compile, what this is going to do is give me numbers 1 through 6. So I'm going to do that. I'll do a list range of that, and then I want to pair these, each individual like card number. I want to pair this so that what I'm left with at the end is a total card count. So initially, the card count's going to be 1. So by the end of this, we should see 1, 1, 2, 1, 3, 1, etc. And so this is our mapping of how many copies of card 2 do I have, how many copies of card 3 do I have, etc. And so if we make this a dictionary, so a dictionary is a data structure that comes in the core library of Elm. We're going to import it though. It's not imported by default. And that allows us to map keys to values. And that also allows us to quickly look up like, hey, how many card number 1s do I have? So we can do stuff like that. So what I'm going to do is I'm going to say initial dictionary. This is going to map card numbers to card counts. And notice that I said, sorry, let me just finish typing and then I'll come back to that. Notice that I said out loud, I said with my mouth, this int represents the card number, and then this int represents how many, like what's the count of the cards. I said that out loud, but I typed int and int. So what we can do is we can use Elm's type aliases to really make this code easier to understand. So card number is just an integer, but with this we can annotate our code so you can see this is a dictionary mapping card numbers to card counts, even if they're secretly ints under the hood. I use these pretty sparingly in Elm, but sometimes it's really helpful for context when you're trying to communicate, like I've got int1 and int2, what do these integers represent? Because without units, it's a little bit hard to understand. So if I hit compile, let me format the code again. What we're going to end up with is just the initial dictionary. So the initial dictionary tells me how many copies of each card do I have, and then the list of matches is going to tell me I'm going to be able to go through those, use this dictionary, and what I'm going to try to do is I'm going to try to accumulate. Um, I'm going to try to add information to that dictionary. So as I make copies of cards, I'm going to do inserts at certain numbers in the dictionary, and hopefully the result is that we'll have a total um, value where we just sum up the dictionary's values at the end. So my goal is at the end of this, we're going to be able to say, all right, you've got your dictionary. Let's just get the values. That's going to give us 111. And then if we do our favorite, we're at the end of every single puzzle, we type list.sum. Right now, this is saying that if we don't run any logic, we have 6 total cards, and that's right. So the only thing we need to do here is working left to right, and order matters in this. We do want to start with card 1, make copies, and then use that information to keep making copies. We're going to do update the dictionary, and we're going to say this is the initial state of our dictionary, and we're going to do this for every single match, one step at a time. So the only function left to implement is update dictionary. So update dictionary is going to take in an integer. I think we also need to pair. We're going to want to pair each card with its number. So before I get too far ahead, let me just comment this out so we can see what this total score count is going to type. I'm just going to comment out some stuff for a second. We have our index for each number in the list. So if you remember, this was what we started with as our input. This is how many matches we found for each scratch card. What we want to do is we want to pair it with its card number. So index map is going to give us 0, 1, 2, 3, 4, 5 for the indexes. So what we're going to do is we're going to take that index and we're going to say index plus 1. We can even make this a record to make it clear. So the card number is actually going to equal index plus 1, and then the number of matches is going to equal the second value here. So index map basically allows us to loop through a list and kind of get access to the index. So if I return this, what we would see is that card number 1 has 4 matches, card number 2 has 2 matches, and so we don't lose that information. And so hopefully with our puzzle input, all these cards are numbered, but I think even if they're not, our logic will still stay the same. So that's it. So let's go back to this. And what we want to do is we want to write this update dictionary function. We want to call this list.fold. And the goal is to take in one of these as input and then return one of these as output. So we're going to take the current copy of that dictionary and we're going to modify it based on the information that we have. So what is our card number? This is that record that's coming in for each phase of the loop, our card number, and then we have matches, which is just an integer. Up to you if you want to use the annotation here. Because we have card number, it's not such a big deal, but I think it's really helpful when you can't in these cases where you just have an int. So I'm just going to use integer here because I'm already labeling. I'm just going to use integer here because I'm already labeling the field with card number. I don't think it's going to be ambiguous in that case. So card number and matches, we're going to destructure that out. We're going to take our dictionary, however it was, and we are going to return the updated dictionary. Here what the code is doing is it's just returning everything as is. So you'll notice that the dictionary we had at the beginning has not been changed. So what I want to do is I want to take a look at the card number, take a look at the matches, and then with that information, I want to be able to find out what card copies I'm duplicating. But before I can really update the dictionary, I'm also going to need to remember to check my dictionary to see how many copies of the card I should be running. So that was a lot to say. Let's just start. Let's just start with one step. I'm going to comment out. I'm going to copy this for 1 second. We're gonna do this for one card. I think this will make it easier for me to like walk through what I'm doing. So we're gonna keep the original input here. And then what we're gonna see here is we're going to see here is the result of running this code once. So list dot, sorry about the underscore. So this is going to be the cards impacted. It's going to be the range of one, or sorry, it's going to be the range of the card number. Oh, whatever. Before I do this, let me just run this. What you're going to see is that we're only going to have one element in our dictionary because we ignored 2 through 6. So all I did here was I just said, let's ignore 2 through 6 for now as I kind of walk you through how I'm going to solve this. And then we're going to add this back in. It's kind of hard to understand a list.fold when there's so many elements and they're all happening at once. So hopefully this will be useful to you for like educational reasons. We'll see. Okay, so what we're trying to do here is the first step is we have card number 1, and we know we have 4 matches, right? So if I were to just return, if I were to do some debugging, I could say debug.log, how many matches, what's the value of like matches when we run this? So if I take a look at our logs, when I run this code, it's saying we have 4 matches. This is kind of like a console log in JavaScript. It's saying we have, we're at card number 1 and we have 4 matches. So these are the values that are coming in. And then again, our initial dictionary that's coming in is saying we only have 1 copy of card number 1. So card number 1 maps to 1 card count. So what we want to do is we want to see how many, make some local variables. So how many cards do we have? So how many cards we have is going to be an integer. And the way we find out how many cards we have of this specific type is we're going to use dict.get. We're going to give it our card number as a key. Remember, the dictionary uses card number as a lookup, and it'll return card count. So we're going to use that on this dictionary. And then if for some reason we can't find our card number, we're just going to say 0. But this shouldn't happen. And then I'm just going to print out using another kind of print statement here how many cards we have. And I'm just going to format this so it's a little bit more spaced out. So here what we're seeing is when we use this dictionary, we give it card number 1, it's saying that we only have 1 copy of card number 1. So what we can do is we can say card numbers copied. This is going to be a list of numbers. We're going to say if there's no matches, so if card number 1 didn't have any like matches in the scratch off, then we're not copying any cards. That was part of the puzzle, but I'm gonna use this just to be safe. But if we do have matches, in this case we have 4 matches, what we want to do is we want to start at our card number plus 1, and then we want to go all the way to, I think it's card number plus, is it plus the number of matches? Or is it plus the number of matches plus 1? This is actually what makes the bugging like this really nice, is that you can print stuff out as you go. So here we're saying that we're gonna make a copy of card 2, 3, 4, and 5. So far our logic's good. So that works. We're saying let's copy 2, 3, and 4, 5. We say we're going to copy it this many times. So what we're going to do is at the end here, what I'd like to do is I'd like to take how many cards we have, and I want to repeat the list that many times. So list.repeat. Does repeat work on a list of lists? I think list.repeat will give us a list of lists. But then we're going to want to smush those back together. Okay, cool. So this gives us a list. What I was saying before is that we're going to repeat this 1 time, and it's going to put it inside of a list. And so to get it out of the list, we'll want to do it as many times as we have cards. So that's a little confusing, especially in this situation where we only have 1 copy of the card. But if the cards, if we had 2 copies of the card, let's imagine that was the case. Oops. Then what you would see is it's gonna, yeah, it's going to copy 2, 3, 4, 5, 2, 3, 4, 5. It's gonna do that many copies. So what we can do is we can loop through the card numbers that we're copying, and we can update our dictionary with that list. So what I want to do is, one, I want to get rid of the hard-coded number 2. That's no good. I want to get rid of all this debugging that we did. I think our debugger is, I think our logic's in the right spot. I just wanted to kind of help visualize that stuff with the debug logs. Let me know in the comments if that was helpful or confusing. Cool. So we have the card numbers that we want to copy. We have our dictionary. What we want to do now is we want to update our dictionary with kind of the copies that we have. And I think the easiest way to do this is with a merge. So we're going to kind of combine 2 dictionaries. I'm going to see if, yeah, dict to merge. So how merge is going to work is, it's crazy. So the problem with these unions and these intersections is that it's going to discard information on one side. So I don't know if that's what I want. Sorry, so I basically have 2 options. I could take the card numbers we're copying, I can loop through those, and then I can update the dictionary to just insert, do like a +1 if it finds a match. That's probably what I should do. Let's do it that way. So we'll start with the cards that we want to copy. We're going to do a fold again, and we're going to say add card number to dict. And then we're going to give it the dictionary as it came in. And then all we're going to do is make one more function. It's going to take in a card number. I think this is a good use of the annotation. It's going to take the card number in. It's going to take in one of these, and it's going to return those also. So this is going to be our card number. Our dictionary. And what we're going to do is we're going to say dict.update at that card number. If we find a value here, case where we maybe have a card count, because remember the values for this dictionary is a card count. If we do have a card count of just some count, we're going to return that count +1 because we're adding that to the dictionary. Otherwise, we're going to say, okay, this is the first card you found. Great. We're just going to add 1 to it. So hopefully by the end of this, I give this the dictionary, I format this, go to output and do compile, what you'll see is that running this successfully made 1 copy of each of the cards. So this isn't the answer to our output because we are only doing it for card 1. But what you'll see is when card 2 runs, instead of it saying it has 1 copy of card 2, it's going to have 2 copies of card 2. And then it'll have 3 copies of card 3, 3 copies of card 3, 4, etc. And so what we want to do is we want to copy all this and see if the values that we get, all these got formatted, that's annoying. Let's go back over here and copy it without the indentation. Some issues, I think, with the spacing. So what it's saying is we had 14 copies of card 5 by the end. Let's see if that's right. Is that what the puzzle said happened? 14 instances of card 5, 8 copies. 8 instances of card 4, 4 copies. So here we had 1, 2, 4, 8, and 14, and then 1. And so the output that we're seeing here is 1, 2, 4, 8, 14, and 1. So these are the numbers we're looking for. We don't care about the card numbers anymore, so we're just going to discard the keys, and all we care about is the card counts. And then at the end, we're going to use our list.sum, and that's giving us 30, and that's the answer that the puzzle was looking for. So the solution that I showed you below, this is all going to be in the video description. If you need more time to look through it than this video gives you, please do check it out. read through it, fiddle around with the code, see how it changes. Um, I know it's probably hard to digest all this at once, but hopefully the way that I'm saying it makes it less confusing than just reading the code cold. Maybe it makes it more confusing. Who knows? Um, but what I'm going to do here is I'm going to save this part two. I'm happy with this result. But what we should really check is to see if it's actually right. So we're going to take the puzzle input, massive set of cards here. I'm going to paste that in. Hopefully it doesn't crash. We did a lot of inserts and stuff, so I'm glad it finished. It says 14624680. Let's see if that's the right answer. And it is. We did it. We are 4 for 4. All right, Advent of Code champions. We got 8 stars. It's a very exciting time to be alive. All the solutions, they'll be available in the bottom. Thanks for hanging out. I'll see you tomorrow for day 5. I'm feeling pretty good. Yeah, I feel like that was a fun puzzle. But yeah, see ya. Goodbye.